you guys, in case you're just not here today and need to watch it later because you don't remember anything that happened in class. Hopefully that's not you. Our goal today is to do section 3.5, but we get to finish it on Monday. Praise the Lord. Sound good? Yeah. So homework 3.5 is due on Tuesday. Sound good? All right. So we're going to go ahead and grade homework. Start 3.5. You guys are supposed to get corrections in and done by the end of today. But feel free to come in during lunch or after school if you need any help on finishing those. Okay? Cool beans. Let's go ahead and get out of the calendar. Let's get back to our checking. Color pens at the ready. Hey, extraneous. We talked about that yesterday. Go team. Number 12, final answer, 10 to the negative 2. 1/100th is the best answer in my opinion, 0.01. All right, fine. Number 16, you have to set them both equal to each other. Look at them making you think outside the box. To find the point of intersection, solving ends up with 9. And then the y value came from g, which was 2. Number 24. Could you, listen, could you have done log base 4? Yes. Oh yeah, of course. But would your decimal have matched at the end? Yes. You would have had log base 4, of 0.10 divided by 3? That's gross. With a negative in front. That's kind of gnarly. Anyway. You could have had it with a log base 4. It just would have looked very, very different, but your decimals should have been the same. They used ln because they're like, whatever. LNs are more natural anyway. And we talked about that a little bit also. So anyway, 0.554. And if you did not find decimals, write down 0.554 and check it later and see if you're right or not. Number 30, the first step was to isolate. Please tell me you divided first. Did you divide first? Good. Then you can take ln. That's just what naturally should happen because you have that e there. Then you can solve. But the final decimal is 0.648, blah, blah, blah. But negative 1/4 ln of 3/40 is the best answer. Hopefully you did not go to a different log. The e was right there waiting for the ln. You could have rewritten it with like subtraction, the quotient property powers, but you didn't need to. 36, the bases don't match. Did we do an example in notes, like number 36? Yes. Just ours had a 2 and a 3. You should have your notes close when you do your homework, and if you don't, shame on you. Why do you think we take them? ln of both sides would have been a great idea. Pull down your power. Distribute just like we did in class. Move everything without x's to one side, everything with x's to the other side, and guys, what happens from one step to the other right here? What happens? What do they do? Factor out the x, divide. Dun, 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 0.181. The whole point was get the x terms so you can factor it out. There should be a 1 left over. 1 plus ln of 2 or ln of 2 plus 1. Number 50, you guys can see it. E is what should naturally have been raised to the power of both sides. You could have squared both sides. That's one way of thinking about it. You could have also made this ln of x minus 8 to the 1/2, brought down the 1/2, and multiplied it to get 10. Either way, you should end up with a 10. Solve. Number 60. I think you had to do some condensing on that one, huh? Condense. 1-to-1 property. Quadratic. Factor, solve, but only 2 is right. Did you guys catch it? Did you check? Did you see whether negative 3 worked? Because it doesn't. It's extraneous. It's not in the domain. The domain has to be x greater than 0 to work for everybody. So negative 3 is a no. 2 is a yes. Number 70, oh, no, we have another one after that. Number 78. We find the zeros, and the denominator doesn't really matter. He multiplies up and goes away, but the numerator is where we're solving. Final answer is E. E to both sides. 84 is a party waiting to happen. Let me give you a second. From what they told you guys, you needed to set the P equal to needed to set the p equal to 169, and then it was a big old equation, but all you have to do is take it step by step, like dividing the 5,000. Like subtracting the 1. Like multiplying by a negative. Then they multiplied this whole nastiness up and divided the other nastiness over. Then subtract the 4, ln of both sides, divide by negative 0.002. You guys haven't heard me say it before, I think I have. E and ln happen very naturally, but their equations are usually quite messy, whether they're being applied in chemistry or physics or in biology or in economics. So just being able to solve, to break down an equation is a very useful skill as far as how to do the math when you have an E or an ln. I think that's the last one, finally. Did we get there? Yeah. Questions on evens or odds? Dean, you okay? Are you sure? You guys are so quiet. Maybe some of us don't have it done yet, so we'll see if we have questions for Monday. Okay. There's head nods to that. If you have a question on Monday on this section, just remind me, because I won't remember to ask because it was supposed to have happened today. But if you have a question on Monday, remind me after you maybe attempt the homework and grade the homework with the video and get back to me on it. Sound good? All right. Here we go. Section 3.5. Carl. Oh, yeah, let me see. Skip one line each. Oh, different problems. Let me see. Okay. Oh, 9. Oh, right there. Okay, so let me see. So I'm missing 17 close to 19, 20 close to 24, 23, 32 is in the 30s. See if there are any sections missing. No, there's no sections missing. Let me write a little note to the TAs and I'll mark it, okay? Exponential logarithmic models. What? We're still doing exponential and logarithmic. What was the title of the chapter? Exponential and logarithmic. Yeah, we're kind of doing that to the end. What's the end? 3.5. What? You guys not look at the calendar closely?
No.
Wait, what? I thought that. So, starting section 3.5 Friday, finishing, you guys are looking really closely at that, but what you didn't notice was, what else is happening Monday? Starting the review, finishing the, hey, I gave you a day and a half for review, I spread out 3.5, spread out the review. And that's on Wednesday. It shouldn't have been too bad. It can get tricky at times, but as long as you have your rules right, they're just little baby puzzles, right? So is 3.5 going to be any different?
No.
I don't think so. We don't really have any new math to work through. We don't really have any new math to work through. Now, if for any reason you're freaking out because you're like, that's rough, really only one homework and a review, and all the properties that we've been practicing over and over and over and over again. If anything, this should be I'm not as scared, unless you have fallen behind, have procrastinated, then maybe you should be very afraid, but maybe you should learn from that. For next time. To not fall behind. Otherwise, don't be afraid. And if you are afraid, let that drive you to working hard this morning. Just saying. You're supposed to learn from your mistakes. What'd you say?
mistakes from that one mistake.
You're gonna keep on making mistakes, that's true. But hopefully we're learning from them. Alright, identify the proper model to use. It depends. It really does. It depends on the wording, it depends on what they've given you. We do have different models that I'm gonna explain to you. They're not so much for you to memorize, but for you to understand what's going on. So the different proper models, I was going to say look in the section because we're about to cover what those proper models are, okay? Proper models, that's kind of what we're going to talk about for the rest of the notes before the examples. Identify the variables involved. You're going to have to basically state the givens. And we know in stating givens, we know in any word problems, right guys? You don't want to write the whole paragraph, so we try to look through, read, pick out the main players, pick out the main quantities, the main variables. You have to identify who they are. Just state the givens. What have you been given? Who have you been given? What different quantities are you working with? And then number 3, plug in the given quantities, solve for what's being asked for. Isn't that just kind of like finish the problem? Take what you have, plug it in. Take what you have from the givens, plug it in the right spot, and solve using the correct math. So use all the rules that we've talked about this chapter along with the things from all the maths that you have ever learned before. So, here we go. What are some different models that you might see? First one, exponential growth. Let me zoom in, let me make it a little bit bigger. Sorry, my ankle's being really funny right now. Exponential growth versus exponential decay. What do you guys see as the big differences between these two different models? Yeah, mathematically speaking, the equation, all there is a negative in the argument, a negative in the exponent, and you know what that does. Doesn't that just vertically flip? So instead of the exponential swooping up, what's it going to be doing?
Decaying.
Swooping down. Yeah, it's going to be decaying. So it's not really super crazy. You have an exponential equation. Maybe there's an A, maybe there's a B. We have to leave room for them just in case we need some sort of like coefficients. But exponential growth is swooping up, exponential decay, whatever, there's a vertical flip. Nope, sorry, horizontal flip, negative on the inside. So it's swooping down. Exponential decay is used a lot in like radioactive decay. That's going to be exponential decay. Decomposing bodies have the exponential decay. Healing from a virus? I don't think healing from a virus would be exponential decay. It'd be nice if it was. Getting a virus is exponential growth. Population growth, that's exponential. And another big key one. Oh no, where are you? There you go. Interest.
How'd you do that?
Interest. Interest. That's an example of exponential growth. If you're going to star any models this section, star the financial one. Star these two. If you're going to star any formulas this entire section, star these two. Everything else is more just understanding, oh, it's going to be going up, oh, it's going to be going down. But the interest are specific types of exponential growth that you're going to need to plug into. There's either n compoundings per year or continuously compounding. Yeah, it's E as in the natural number. Remember I said that E naturally occurs? Hurt, yeah, hurt. P is the principal, is the initial amount. E is, well, our natural number E to the RT, rate times time. But on top, it's per one or I don't know. That doesn't really work as well as PERT does.
One right now.
One right now. What's NT?
There's a punt.
Punt?
There's one punt right now.
Not.
Punt.
And then not.
That kind of works.
So an arm. What did that say?
It could be like,
One
anyway.
punt.
This is P times 1 plus R over N to the NT. Bunch of this stuff. I don't get that.
What is the second formula?
So it looks like pint.
P times E to the RT. It kind of looks like pint.
I see pint. And then
Pint right now? Pint right now makes more sense.
pie right now. Okay.
Pie.
What's pistachio?
Higher? Turn? We should probably just stop making up words. That gets dangerous really fast. Okay, so p times 1 plus r over n to the nt. The nt is really like light because it's small. And then this is p times e to the rt. In finances, A is going to be the amount of the interest. Is the amount of the interest. P is the amount that you put in the account to begin with, the principal. R is the rate, wherever you find them. N is only present in n compoundings per year. So that would be, let's see, if I said it compounded monthly, what would N be? Yeah, daily. 365.
365.
Bi-monthly. Be every other month, so 6.
20.
Oh, so that's a good idea. That would be bi-weekly, every other week. That would be about 20. Okay, anyway, so we have formulas for compound interest. You guys started them, right? Okay. Any more models? Yep. Pause. Remember I said the only ones to highlight the entire section are the financial ones, right? Okay. So we're writing these down just to see what they look like so that we can match them, or if we needed to answer like in a homework question which model we're using. But don't worry, you don't have to memorize them. There's Gaussian, that has to do with standard deviations, with statistics, normal distributions, all kinds of crazy stuff. That'd be an example of a Gaussian curve, which is also exponential. Logistic growth, actually that's more of the virus spreading. At some point your population that can catch the virus has to be limited. Logistic growth, it's exponentially growing until it starts to get limited.
Wait, what's the square root of, is that raised to the power of 2 over c?
There's another way of writing this, just if it helps. y equals a times e. Like that. It's negative x minus b quantity squared all over c, all in the exponent. Gaussian could be used in economics, could be used in business. Logistic growth is used in population, maybe I shouldn't say control, but population studies. How's logistic growth shown? Spreads of viruses. It's like disease control. Probably more. Those are the first few that come to my mind. So once again, don't stress about getting the exact examples. Unless you want to get them down, it's more just getting the general curve, the general shape. Logistic growth does have a horizontal asymptote at 0, but also at some high point, which would technically always be at, if it's written correctly, at A, at the top number. I'm going to go ahead and dual page just because you guys realize these light blue things you don't need to write down. That's just what the actual model is that you're looking at. There's only one more. Logarithmic models. And you don't even need to write more than one. I mean, you can. Remember, the common log button and the natural log button, they are in your calculator because they are the most reoccurring logs that are used in different applications. And basically, guys, this whole section is just to say exponential and logarithmic functions are used in a lot of different modeling of different scenarios. And I think I had mentioned it earlier today in chemistry, and physics, and biology, and economics, and math, obviously, but that's not applying it. Did I already say business and finance? They model a lot of what we would say is the natural phenomena in these different fields. Okay, so what are the formulas I told you to highlight or to star?
K equals P times 1 plus R.
Good, the finance ones, the n compoundings per year and the continuously compounding, but otherwise you're not going to have to memorize any of these. You're just being exposed to, wow, they get used a lot. A couple more seconds for any of you guys still sketching or still writing, but we need to get to examples. We need to get to word problems and try to figure out what on earth is this section going to have us do. Take a second, start reading. I'll make it bigger in just a moment. A few people are still finishing up the last category. Man, this is talking about tables and scatter plots and exponential functions and function notation. So much math in one page. You guys had to write this down in your homework, not wanting to write down the whole page. How would you summarize it? Ready, set, go. Practice in your notes. What are the givens? First of all, what's the scenario? Online spending. Online, not, I shouldn't say that. Online advertising spending. It's very different than just online spending. Online advertising spending. What would you need to write down as your givens? What's one thing you think you should write down?
Equation.
The equation, definitely. The table, probably. The sketch, maybe. Yeah, because the table is a sketch, sketch is the table. Which one's more precise, the table? Yep, I'll take it. But you might want to label things like the years. Are from 2011, so technically wouldn't the table be 11, 12, 13, 14, 15?
It's measured both.
Sorry, measured from 2000. What are you saying?
You have to know what it's measured in.
Billions of dollars. Good. So I might put the years is just 11, 12, 13, 14, 15. Spending in billions of dollars. And then the equation. Once you have that information, P.S. double check your decimal, 0.1129 t. What are they actually asking? With all of that given information, what is the one thing they're curious about?
When would be $1 billion?
What will what be?
Money, dollars.
Being? Which is what variable?
X.
So basically, when S equals 80 billion, find
T.
Got it. It's a great way of summarizing that bottom paragraph. When S equals 80, find T. Wait. Do you really need the table?
No.
It's okay. Some of you guys decide to read and write at the same time. Some of you decide to read quickly and then write. If you've gotten to the end, I think we only needed the equation, but hey, that's all right. Long story short, how do we solve? By plugging in. Now, if you want to be super lazy, in like a future, I don't know, like econ class or something, you could technically, if they allow you to use your calculator, you could just plug in 80 as y1, and 9.30 e to the 0.1129t as y2, and couldn't you just find the intersection? If you're allowed to use your grapher? But would the window have been nice? You have to get to 80. I don't know if the window would be nice. It might be easier just to solve by hand, because how do you solve by hand?
Reverse it.
You can't reverse until you isolate. What's the very first thing you gotta do? Divide. You gotta divide by 9.3. Then you can look at your E and say, ooh, what do I need? Yeah, looking at that E, I need an ln to undo the E, right? What's the last step to solve for t? See if it makes sense. What's just a little bit of math, you can just say, oh, hey, I can plug it into my graphing calculator, no problem. I think Colby's doing it. Does it make sense what I did? Divide first, get the e alone, now ln both sides. Now say, oh, it's just a coefficient times t, divide that puppy, which is the same thing as 1 over, or you can do the whole thing over. It's kind of gross when you go to type it. And solve. Technically, yes, but you know in math how we usually put the thing that we're trying to find on the left? I just swapped the equations. I swapped the sides. So I divided and I said, ew, I don't want the t on the right, so I wrote them on the left and I switched it.
Oh,
Does that make sense?
I'm trying. 19.006.
Now hold on. Oh, 0? Oh, 0? 6? Okay. Let's say you were presenting this to someone. They asked you, you solved, and then you're presenting it back to them. Would you say, oh, don't worry, 19.061, that's when we're going to have it?
No.
That doesn't make any sense. 2019?
Wait, on the 6th day.
You could figure out when .061 would actually be within the year, or you could say somewhere between
19 and 20.
Yeah.
2019 and
2019 and 2020. What?
That's when we're graduating.
To be honest,
One of us will be the lucky class.
where it'll happen. But this is just a prediction, right? All models are used for prediction. That's what we think will happen when it will happen, which is a lot better than trial and error, but still not as precise. It's not sure fact, we'll put it that way. What kind of model is this, guys? Just looking at the equation. The one that we just looked at, that was exponential growth or decay? Exponential growth. We couldn't really see it in the scatter plot yet, but eventually it's going to have to start taking off according to our model.
Logarithmic.
But what's this one? Logistic. Logistic. Let's see how a logistic model is used, or what it can be used in. What's going on? College campus of 5,000 kids. One student returns, oh dear, this always happens, from vacation with a contagious and long-lasting flu virus. Go team. What happens when you're in close quarters with other people?
They sneeze on you.
It spreads.
You cough and people stop.
So the spread of a virus is modeled by, the logistic growth can show the spread of a virus. Where Y is the total number of students infected after T days, the college will cancel classes, interesting, where 40% or more of the students are infected. Important step to write down, I don't know, flu virus on college, campus. 5,000 kids, the equation. Y is the number of kids, T is days. Cancel classes, 40% or more infected. Letter A, can you rewrite that in a mathematical way? Can you put notation? What are they saying? How many students are infected after T days? T equals 5, find. Yeah, find Y. Letter A, mathematical way of saying it is find Y when T equals 5. Well, guys, that's the same thing as just plug it in and chug it. Plug in, chug in. Some people are already on it. Perfect. A few of you guys are still summarizing the problem. That's good practice. Some of you might be noticing, sorry, real quick, the 5,000 on top, that's also how many kids maximum could be infected. Okay, Colby, what'd you get?
91 students.
Do you agree, Kevin?
51 students.
Uh-oh.
56.
We need a few more. 54?
Yeah, I'm off.
Isn't it around 56?
We round it's 56. We have a 54-ish, 56-ish, 90-something. 5 days. How quickly is this thing done?
I think he's good at
plugged in wrong.
54. Uh-oh, another 54, now we have 2 people. Uh-oh, another 54.
Yeah.
Okay, so then 54 point what?
Oh no.
0.19.
Well, we're not gonna cut off someone's leg and say that's infected, but that person's not, so we're gonna round up.
Oh, what county?
If 0.019 of a kid is infected, we'll just say 55. Why can't we? It's a little disturbing. Yeah, cool.
I got 5,091.559.
How do you put it in?
Oh.
What do you see?
And put parentheses.
Oh, round to 1 plus 499.
Oh.
Yeah. You can always use your alpha, what is that shortcut, guys? Alpha y equals, you can use the cool fraction button, right? But if you are typing it the old-fashioned way, 5,000 divided by, you do have to close in the whole denominator. That's true. And for e, you have to close in the e exponent also. Otherwise, it might be confused. But what's letter B asking? Okay, so what are we finding? What variable now? We're finding days, which is t. So find t. Uh-oh. When they just said cancel classes. What's going on? 40% of the student body, which is 5,000, are infected. Does Y stand for how many are infected or aren't infected?
2,000.
Are. So what's 40% of 5,000?
2,000.
2,000. So it's when Y equals 2,000. Ooh. Could we mess around with our window and try to graph like I showed before, if I can actually get this to work. Hold on a second. Let's take that equation, set the Y equal to 2,000. Help me out, keep me honest. I know it's 5,000 over 1 plus 4,999 e to the negative 0.8 t. Is that right? Okay. We could graph. This one's y1, graph that one's y2. Find the intersection using our graphing calculator, but we have to play with our window a lot. Some of you, that might go faster. But for the rest of us, what's another way of doing it without having to use our grapher? Okay, multiply the denominator up. And can we divide the 2,000 down? Pause, can you guys follow me? If we multiply this up, can't we divide the 2,000 over? Okay, so I'm going to get 1 plus 4,999 e to the negative 0.8 equals 5 over. Is that okay? Multiply up, divide down. I think a couple of you are trying to do the graphing thing, see if you can beat me. That's cool. I'm a fan. Now what? Subtract 1? Now what? Divide by? Some of you would do this in your calculator like over 10 different steps. Just be careful, it's super dangerous. Then we have ln. We can say t is equal to 1 over negative 0.8 ln of. If you want to be super snazzy, you can just leave it like that. Although I don't want to type in more than I have to, so 5 halves minus 1 would be 3 halves. Plug that in, don't have to worry about a window, you got it. Now once you get really good at it, you could probably jump to that answer, kind of mental math style. Not mental math as in knowing what the answer is, but going through all those steps of the process of multiplying up, dividing over, subtracting 1, dividing by 4,999. I put way too many 9s.
Wouldn't the 0.8 be positive? Can you go more?
Say it one more time. Which one?
The 0.8.
Oh, actually, I don't know. I wrote down the formula. Was it supposed to be positive?
No, you got it right.
No, you're right.
Okay. So the reason why it's going to stay negative is because when we divide over, we're going to divide the whole thing. So we could have divided the 0.8 and then the negative, but either way it has to come with. You could put the negative on top if you want. but it has to go somewhere. Does that make sense? Yeah, it has to go somewhere.
What was the answer for
Oh, A was, I think, 55 kids. It was technically 54.019, but if like a part of a kid is infected, we'll just round up and say the whole kid is infected. Yeah, I multiplied up and divided. Then I got to take away the 1 and divide the 4999. Then I had to take ln of both sides to undo the e. So I just reduced that real quick. I didn't want to have to write more than I needed to. At which point you only had this left, so you divide that, which is 1 over. And I just subtracted, 1 is 2 over 2, so 5 times minus 2 over 2 is 3 times. But it's totally fine if you leave it in, you just have to type it in carefully. Who solved it? Anybody?
10.113.
Oh, I heard 10 and 12.
I mean, if you round up.
What? No, if you round up, it should be 10.140.
You mean 11?
It would be 11 days.
Yeah, but then
11 days. Wait, wouldn't it
So it
happen
was like
on the
10 point
10th
what?
day?
10.139. And I did both ways. I did the graph and
Going 1 too high down. 10.139 would be, okay, so when the 10th day starts, enough kids infected?
no.
No. Now, if the administration's really nice, like, okay, well, by the end of today, we'll have enough, like, it's spreading, we're in trouble, they would cancel classes. But technically, if it was a mean administration, what would they do?
No, 11.
11 days.
Leave the campus.
Are these gonna be in the test?
Not too many, right? But, wait, pause. Some of it is translating, right? Some of it is translating. But some of it is just carefully solving. So there are 2 steps to any word problem. Reading and translating, what are they giving me and what's given and how can I plug it in? And then just step 2 is solving it. So it's making you practice all of your skills. Hold on, don't need that page. We did it all on the page before.
Yes.
Oh, wow.
But
Oh, wait, no.
we were supposed to
No.
today and Monday.
No.
So we have an extra.
Okay, we have an extra. Listen. On the calendar, I have half of the day Monday for 3-5.
Oh, it's because you put
Let me have you guys write down homework. Half the day Monday will be a work day. It's up to you as to how you spend it in honors pre-cal, not for another class. Could you be finishing homework?
Yes.
Bring your books on Monday, or I have a few spares. Half the day will be finishing 3.5. I'll also have up on the board the chapter review, so you could be starting on the chapter review to ask me questions on Tuesday. But long story short, I have spread the test out to be on Wednesday, not on Tuesday. So Monday can be a catch-up day. Sound good?
Yes.
Not a mustard day. All right, so let me go ahead and show you. Homework spiral's open. Write down the homework. But pause. The workday on Monday. Do you think maybe you'll get stuck on a few of the word problems?
Yes.
So maybe if you can at least start it over the weekend, you can come with questions and the workday can be me explaining some stuff in homework. Could be a good idea, but we'll plan on half the day being a workday. Maybe it'll be mostly me going over some of the, or my going over some of the more confusing problems.
I gotta learn.
I would not make Monday the first time you start looking at 3-5. I would not make Monday the first time, but you have to totally finish it this weekend, yeah.
Do we need to like memorize the interest formulas for the test?
No.
When you get to homework, you'll see that they don't really give you the interest, they just give you clues and you need to know the models, so yeah. But in the other things like logistic and Gaussian, they would give you the equation, you're just using it. The interest ones are kind of like more common knowledge. I'll peek at the test on Tuesday just to make sure, and I might be able to narrow it down to only one that you need to make sure to have. out of that entire section, that's the only one you really need to stress about. Just even kind of the life and how you go. You guys good? You chilling? What test do we have left today?
History.
Chem, history.
Good.
Hey, Andrew too!
I'm here, best thing, I'm missing my AP bio test on Monday. So I gotta do that for school. It's a 65-minute test.
Ooh, yes! Hold on. Carl and Rebecca. Is there anybody else in sports med? Okay. You guys are gonna be gone during the test on Wednesday, but Mr. Payne offered to me, actually to everybody, if there was a test you're missing, to take it during 6th period. So he never ate, maybe he knows that. I'm gonna put the test in his box, he'll grab it, and then he'll have it to you guys. But you guys can feel free to have like music, so you can put it in to walk out, whatever. Super productive stuff is going on otherwise.
Oh, yeah.
Oh, yeah. Okay.
I have to coach little kids for 2 hours.
Until, like,
Oh, you're
the,
cool, kid. Hey, Rob.
like, training
That's my
facility
test.
in my town.
Oh, okay.
That's your test. When's that, this weekend?
No, should have.
No, we are.
What?
Yeah, so because we're talking about
I can Google how.
I don't know if you tell me that's something.
Yeah.
Did you say that?
That's funny. I didn't hear you say Mozart, so at least I didn't get it. Bye, Ryan and Thomas.